11.13. A copper block of mass 2.5 kilogram is heated in a furnace to a temperature of 500 degrees Celsius and then placed on a large ice block. What is the maximum amount of ice that can melt? Specific heat of copper, that is 0.39 joule per gram Kelvin. Heat of fusion of water equal to 335 joule per gram. Now see, mass of copper block 2.5 kilogram. Change in its temperature. So initially it is at 500 degrees Celsius, and when we place it on the ice block, it implies that its final temperature that will be 0 degrees Celsius. So change in temperature, that is 500 degrees Celsius. Specific heat of copper, that is 0.39 joule per gram Kelvin. Latent heat of fusion for ice, that is 335 joule per gram. Now first of all, we have to calculate the heat lost by copper. So we have the equation delta Q, that is ms delta T. So delta Q, the heat lost by copper, that is mass of copper 2.5 into 10 raised to 3 gram. Specific heat of copper 0.39. Delta T, change in temperature, that is 500. Solve this one, you will get the heat lost by copper. Now this particular heat is absorbed by ice, and that will be utilized by ice to melt. So here suppose maximum m gram ice is melted. So amount of heat required to melt m gram ice, that is m into latent heat of fusion. So we can write delta Q, that is m into latent heat of fusion. So the mass of the ice, which one is melted, m, that is equal to delta Q upon latent heat of fusion. Delta Q, this value, substitute here, latent heat of fusion, that is 335. Then solve it, you will get the amount of ice which one is melted. Clear to all of you?